Okay. Solution? Anyone? No? Didn't try?
Didn't even try it.
Didn't. I'm sure you're the only one.
Yeah, just being honest.
Okay, if I call this P and there's LP and there's JP. What decision variables do you want? Laughing, it's a serious question. Anybody have any decision variables in mind? Yeah. So what are they? The problems.
Programs.
Well, the programs are decision variables. Programs are got the Voice UK. This one. Don't know because I don't. That's why I called them 1, 2, 3, 4, 5, 6, 7. Couldn't think of 8 different programs. I don't think. Okay. Oh no, the voice is like 60 minutes or even longer. You need a lot of patience to watch it. Anybody have decision variables? Yes.
XP, which is a binary, if it's 1, you watch program. If it's 0.
Excellent. XP for each of them, 1 to 8. And it's binary, and XP1 means watch program P. And XP is 0 means don't program P. What's the objective? Is that right? Any questions, anyone? Okay, that's right. So, what are the constraints? So what are the constraints? No more than 2.5 hours.
So is 1 to 8 of LPX.
Yes. Well, of course, this uses the non-trivial calculation then, so that 2.5 hours is 100. You can watch no more than one of 1, 2, and 3.
x1 plus x2 plus x3.
I'm starting to be very optimistic about the exam. I mean, collectively, you'd be able to do it. See how that how it works out on an individual basis. Yes, x6, x7, and 1. Okay, what is this one? You don't want to watch 6 unless you also watch 4.
Would be x6 is less than or equal to x4.
It would be. Something. A few spares. Did you grab them from this present?
I should look up the model solutions.
It's always the same. So partially that answers the question that was asked last week, whether the exam problems are as hard as the electricity generation problem, which is a bit simpler. Is it not? And decision variables.
Need an alpha j, which is 1 if it's used and 0 or less.
If line is used. Okay. And
And an xj, which is the amount of problems that uses.
what did you say you wanted to call it?
Xj.
XJ?
Why?
Matter. I don't have any preference. So XJ is, what should we call it? Probably best number of bobbins produced on lathe J in thousands per hour. Question is related to the first year assignment with copper zinc, because the wildfire forest, because copper zinc provides the wood. So these are the decision variables. What is the objective?
You want to minimize the sum of all the j's and j's of alpha j times by the fixed cost, which is a plus
You want to minimize the sum over all j in j, alpha j times the fixed cost. What's the fixed cost? AJ.
plus the unit cost, which is uj times by the amount. So
Plus uj times xj, like this. What's it missing?
uj from the decision value.
Sorry?
Uj from the decision. Actually, again, I'm very clear.
I didn't quite get that. uj from the decision. No, xj. uj are not decision
We should
values.
aim-
uj are
Actually,
up here as the cost. Yeah. So no. So uj is not a decision variable. aj is the cost here. Maybe I should have. I was too lazy to repeat this. And in the answer, when you're doing the exam, actually, you don't have to repeat the data. You can, if it helps you. If it helps you formulate the answer, you can write down neatly what is given. AJ, J, Q, and NJ, and J. You could do, but it's not necessary to put it there for the correctness of the answer. Just start with the decision variable's objective constraints. That's enough. So EJ is part of the parameter. This shouldn't be greater than or equal to anything, but what's it missing? Where it's missing is brackets, because if you don't put brackets, then the sum only applies to the first thing. Okay. Look, it's a book. It's wrong without them. Constraints.
Sum of all your xj's is going to be greater than or equal to the demand, which is q.
Sum of all these xj's should be at least q. I agree.
Xj is going to be less than or equal to MJ. Only mean the same thing. So like U, XJ. So XJ has to be somewhere between the demand U and the maximum. If it's not the sum of XJ, it's just XJ's got to be less than or equal to not the sum of XJ's.
xj has to be less than or equal to mj.
Just each XJ has a maximum. Not all the maximums need to be added.
Objection withdrawn. Yeah. Okay, tentatively, I could accept this.
XJ is going to be greater than or equal to 0. So you can't make a negative amount.
Okay.
Then the alpha J has got to be the belong to 1, isn't it?
Anything else?
Yes.
Because like this. Okay, I'll wait for everyone to catch up. I know exactly what the value of each alpha is going to be in the optimal solution like this. It's going to be a 0 for all of them.
So
Because there's nothing stopping you putting your xj to something positive without putting the alpha j to 1.
the sum of alpha J.
The sum of alpha j is the number of blades that are switched on. We don't know anything about that.
There you've got MJ. Multiply that by alpha J.
Yes, that's what I would do. Thank you. That's the usual trick how you can make things 0 if some kind of 0, 1 indicator is 0. You make it less than or equal to some constant times alpha j. And if you know what the constant is, like in this case, you know that the maximum can't be more than this number. But in situations where you don't have an upper limit of the production, so if you blades were somehow super blades and could do an unlimited amount, then you'd have to come up with a large number that doesn't. For example, you could put the demand there because you certainly won't be making more than some other large number there, whose job will be to ensure that this is 0 if that is there. Is there anything else there that we need? I don't think so. So 10 marks done. I think. Good start. We'll do a couple of accounting questions and okay, good. What else? B. I don't want to do B. We've done B quite a lot. Do you want to do B or do you want to do 8? Or do you want to do now? Well, I don't think we have time to do both now, but we can take a vote if you want, or if everybody agrees that we should do it. Who wants to do linear programming question B? Two votes. Who wants to do question 8, branch and bound? It's more democratically we decided to do this. Right. Part 8. We can't really do it because I don't have it solved. But do you have a solve on your phone?
But I happen to have the model solution here, so I know what they are.
Okay, so in a problem like this, first you need to devise a way to solve linear problems, the BLP realizations. Normally, you take Mosul and write this in. It takes about 5 minutes when you know what you're doing. So go to the lab a few times and practice before the exam. And then do it. Okay. The whole code is in the lecture notes in the booklet. I think it's also on Moodle, so if you don't know what you're doing, learn that. Now, when you solve, so then you solve this whole thing without any integer. When you solve this whole thing without any integer, you're supposed to get 0, 7.5, and 0. So I'll start drawing that tree. I'll call this as S, just to be consistent with that. And x1 is 0, x2 is 7.5, and x3 is 0. Suspicious. Oh no, not very suspicious. Yes. Okay. So that's the solution. Apologies. So if this happens to be all integers, then you're happy and you say, oh, we've won. Optimal solution found. If it's not, then you do what? You introduce new constraints, but in what way? By branching. So you create two subproblems. I'll call them S1. And I'll call this one S2, say. And the constraints you introduce, how do you do that? Yeah, you pick one of the fractional values here. There are several. Well, in this case, it is only one, so that doesn't give us much choice. So one of the sides is less than or equal to 7, and the other side is greater than or equal to 8. Based on 7.5, so 7.5. To the left of it, and then it's almost 7. And it's at least 8. So which one do you want to solve first? S1? S2? Why? Have you done it? Have you done it already? Okay. So this one is infeasible.
That's fine. So this is so next we have to solve S1. What did you get?
X1 is 0.08, not 77. With 2 is 7. X2 is 7. And X3 is 0.60.
0.62.
Yeah, and Z is 21.
I didn't catch this one. I got something small.
Yeah, 0.077.
So now we have a choice. We need to branch again, but we have a choice. What did you pick? Why?
Because I did it with X1.
You picked X1. And in what sense was it not nice?
Just it.
Is there a rule where you're supposed to pick the highest fraction on?
Yes. There is a rule of thumb which is not guaranteed to do anything, but quite a lot of so it's a very simple rule is to pick the one that's closest to 1/2, the most fractional, closest to the farthest away from an integer number. So in this case, this is very close to 0, whereas this is close to 1/2. So that's what you would have to pick normally. But because it's a hard problem, it doesn't guarantee the most efficient way of solving it. So okay, so x3 is better, and it's either equal to 0 or it's greater than or equal to 1. And you can call these problems whatever you want, S3, S4, for example. Which one do you want to solve now? Yeah, I do S3 now, because I know where it's going. But you have no way of knowing. So when you solve x3, what you get is 0.27 what? Roughly. This. And that gives 21.4. So you have to branch. The only thing you can branch on is x1. I want to solve this one for some reason. So when you solve this, you get 0, 7, 0, 21. That's the objective. Do you have to branch? No. So you write proved integer. Oh, it's already all integer. The other one, 17, 1, 5, 0. What is infeasible?
First question. Wait. It's worse than the best integer solution, so it's
Pruned, integer, and also suboptimal.
The last unsolved problem is S4, and you get
0, 6.5, 1. Just a branch? Why not? Because what I should have said is in 21. Now, this is less than 21, so I can say suboptimal. Optimal solution.
because that's actually very close to the first realization, but many times it's not. Any question? So what's hard about this question? What's the most difficult bit? The most bit, that's what you need to practice.
Do you just use Excel?
You can use Excel. In what way?
Use the solver.
And who? We have to be smart about how you're adding these constraints. The limits. So you have to think it through. But you can use Excel. You can use Excel in the simplest method, or you'll run out of time if you do. So I wouldn't recommend it. Okay, and there's part B as well. This was question 8. And this is just like the second part of the assignment. Okay, of course. Sorry? Yeah, IOPs, exactly. So the way it goes is that you say that 5 over 2 x1 plus x2 plus 1 half x3 plus 1 half s1 equals 15 over 2. Therefore,
2x1 plus x2 is less than or equal to 15 over 2. They're all negative. So if you take a smaller multiple of each of them, the sum is getting smaller. On the left hand side. Okay. And problem with writing 2x1 plus x2 is an integer. X1 and x2 are required to be integer. So you can safely say that they're no more than 2, 7. Because they're no more than 7.5. It's an integer, so if it's no more than 7.5, it can't be more than 7 being integer. That's it. And it's split into question 1 and question 2, but this is the proof. And this is the input. So an answer like this will fully satisfy me. Don't try to do any magic. I'm convinced. Three is not included. What? You need to round them all down because otherwise it doesn't work. If you're trying to get something that's less than or equal to this whole expression, have to round them down. It wouldn't work if you rounded them. Okay, main questions about this at all? What else is there? Is it time to go? Yeah. When started. Shall we start 7B? How about 5 minutes? 7B. That's a tough one. So 7B, you're supposed to, nobody remembers these things from term 1. Unless you've already been revising. Which I shall certainly would. Then it wasn't a very good time. So you want to So this is about linear programming, not integer programming. And what you want is the optimal final simplex tableau for this problem without any pivoting whatsoever. If I just give you the basis, the optimal basis. That can be useful in various things. For example, you have you're in the middle of solving something like this, and so you've got a huge problem like this, and many constraints and many variables, and at some point you always want to look at this problem, and then you're adding a new constraint. So you want to start from the optimal solution to this problem, and then just do a pivots to get the optimal solution to this when you're doing it professionally, like a big solver. And then you've got so many, just remember the optimal basis for this problem. You don't have, so because if you remember the whole tableau, then that would take up a lot of memory. So just remember the optimal basis and what the problem is. And then once you get to solving it again, you just reconstruct the final tableau like that. That's an example of what it's used for. How does one do it? How does one do it? Yes. So you have to know that the tableau, what it looks like. So when you have the basis, and this is the B, this is Z, this is the val. So the most important thing is this, the inverse of the MB matrix. And the MB matrix is a submatrix. We take the constraint coefficients and the identity and look at the columns that correspond to the basic variables. So in our case, the coefficients in the constraints are 2 and 1 for x1, 1 and 3 for x2, and then these are the slack columns. You want to take the first and the second column of this. So in this particular case, you don't get anything else than the matrix A back, which is 2, 1, 1, 3. Now, you have to do the inverse. So either you can do the inverse out of the bucket for a 2 by 2 matrix, you should be able to do. Right? Or use MATLAB or something. So how does one do matrix inverses? By hand? Yeah, it's 1 over the determinant. The determinant is 5. So it's 1 over 5. And this is something like something like that. 3 minus 1 minus 1, 2. This is MB inverse A, but we don't have to do it because B inverse is A inverse, so this is the other. This is MB inverse B. So 3 minus 1 minus 1, 2. And B is the right hand side, 5 and 10. It's like 1 and 2. It's 3 minus 2 is 1. Okay. Yes. Now, this is CB MB inverse, is it? Yes. This is CB MB inverse A minus C. This is CB and B. We don't have to do it in matrices. You have to remember that you just look at the basic variables in the tableau, look at their objective function coefficients and times each row by the corresponding objective coefficient and add them all together. And in this part, you have to subtract the original objective coefficients. You don't want to be too complicated. Okay, so in our case, we know this is going to be 0 because they're the basic variables, so we don't need calculation there. CB, that's the cost coefficient, or the objective coefficients of the basic variables, so 3 and 2, straight from the objective here. Basis is x1 and x2. And CB that's this matrix. So you get 9 minus 2 is 7, I think, so it should be 7. Minus 3 plus 4 is 1, so it should be 1 over 5. Yes. And CB and B inverse B is just this times by B, which is 5 and 10. It's disappeared. No. Yes. Is that right? Another way to, so there are two different ways. Like, two different ways to get this. One way is you already know this. And D is the right hand side, right hand side. And the other way is this is the new column there. So you know that x1 is going to be 1 and x2 is going to be 3. You just put it back into the objective. So 3 times 1 is 2 times 3. It works. Okay, it's a lot of matrix calculations without much commentary written down. Any questions? No? Well, let me just very quickly put it all together. Then the answer should be the final tableau looks like this. The basis is x1, x2, z. The values we said were 1, 3, and 9. And we have x1 is in the basis, x2 is in the basis, s1, s2. So what was this inverse matrix was 3 over 5 minus 1 over 5. And this bit here is somewhere here. And that's the answer.
So it's like 40 marks in 45 minutes. That's not bad. Right, that's it for today. See you all on, when is it? Thursday. Friday, no, Thursday.